Well, welcome back to our discussion of the geology of the Caribbean. This is part 8. In part 8, we'll give you an introduction to the Lesser Antilles, and we will also describe the geology of the island of St. Martin. Well, I have to tell you, this is one of my favorite areas in the Caribbean, the area of the Lesser Antilles. See, I like active volcanic islands, and this would be it. Uh, Please refer to the sketch maps that I have provided here for you. Now, the Lesser Antilles is the island arc south of the Virgin Islands. This island arc lies between the Greater Antilles to the north and west and the continent of South America to the south. The islands form the eastern boundary of the Caribbean Sea, and for that matter, the eastern boundary of the Caribbean tectonic plate. Together, the Lesser Antilles and the Greater Antilles form what we know as the Antilles. And the combination of the Antilles, the Bahamas, and the Virgin Islands form what we call the West Indies. So the Lesser Antilles coincide with the eastern boundary of the Caribbean tectonic plate. Many of the islands were formed because of the subduction of oceanic crust of the South American plate beneath or being thrusted under the Caribbean tectonic plate. This process is ongoing and is responsible for the volcanic activity and the earthquake activity that we have in this area. The islands along the South American coast are the result of interaction of the South American plate and the Caribbean tectonic plate. And as we previously mentioned, remember that this southern boundary is a mess, is very complex with strike slip motion and a compressional component. The geologic history of the Lesser Antilles is complicated, as you will see, as reflected in the structure and rock composition of various islands. North of the island of Dominica, and please refer to the sketch diagram, the arc is divided into two island chains. The eastern chain is an older extinct island arc and is covered by thick carbonate platforms. The western chain is where the action is right now. Has been the site of active volcanism since approximately late Miocene. South of the island of Dominica, and again refer to the sketch map, the older and recent arcs are superimposed, forming one chain of islands. At this point, I would like to mention to you some of the important references that you can find that address the geology of the Lesser Antilles. I have listed here the ones that I have felt personally that were most helpful to me. They range all the way from 2017 to as early as 1951. Uh, Listen, some of the older references are really, really good because these people did a lot of good work and have a lot of good descriptions. Uh, all of these references are listed in part 13, which would be the all of the references for the entire discussion of the Caribbean geology. In the parts that follow from this point on, uh, I will give you a synopsis of the physiography and the geology of some of the islands of the Lesser Antilles, specifically the islands of St. Martin, St. Lucia, Martinique, Barbados, St. Kitts and Nevis, Antigua and Barbuda, also the Dutch Leeward Islands of Aruba, Curacao, and Bonaire, as well as the islands of Trinidad and Tobago. I've had the good fortune of having visited many of these islands in this tropical paradise. Okay, now we talk about the island of St. Martin. St. Martin is a very interesting island because it is really two countries in one. You have a Dutch site and you have a French site. Please refer to the sketch map that I'm giving you here. The main cities are Philipsburg on the Dutch side and Marigot on the French side. The highest topographic feature on the island is Pic Paradis, with an elevation of 1,391 feet above sea level, in the center of a chain of hills on the French side. But I should tell you that both sides are hilly with mountain peaks. There are no rivers on the island. Now, sea stacks and sandy beaches occur throughout the coastline, and tilted and folded strata are visible on the island. Again, in reference to the sketch map, notice that two distinct mountain chains occupy the central region and the eastern coast. The latter goes from Point Blanche to Baie de l'Embouchure. And here are some of the views of this beautiful island. You have on the left the typical topography that you see in St. Martin. You also have an illustration of the sea stacks, the beautiful sandy beaches, and the tilted strata you find on this island. In terms of its geological history, we can say that three volcanic phases are recognized on St. Martin, the first two having occurred below sea level. Now, distinct lithologies in the island of St. Martin consist of Eocene andesite, tuff, and volcanic breccia, which have been intruded by quartz diorite, basalt, and younger andesite. Volcanic activity led to metamorphism and the tilting and folding of the volcanic tuff and other rocks. Marl and limestone were subsequently and unconformably deposited over the eroded volcanic rocks as volcanic activity shifted away from this area. The presence of large boulder ridges and solitary boulders on high cliffs could indicate storm and tsunami type deposits. Sandy beaches tend to alternate with rocky coastlines. These rocky coastlines are composed of basalt, limestone, and marl. As you might expect, caves are found in the limestone areas. The oldest rocks in St. Martin are Eocene to Oligocene volcanics overlain by Miocene sedimentary strata. As far as key lithologies for St. Martin, we can say that the Eocene basement rocks consist of silicified volcanic tuff. These tuffs are found along the center of the island, along the eastern coast, and also scattered on the north and west. In the Oligocene, the existing rocks were intruded by a diorite batholith. Quartz diorites are found on the north and east central regions. Oligocene porphyrites and dolerites are present on the western side of St. Martin and around the diorite intrusions. In the Miocene epoch, a marine transgression took place, resulting in the deposition of limestone and marl. These rocks are found from the westernmost point of the island, trending southeast to the end of Simpson Bay along the southern coast. Please refer to the sketch map. Quaternary rocks include coral limestones and alluvial sands. These are found mainly on the westernmost area around Simpson Bay and near Phillipsburg. Well, we have finished part 8. Now we will go to part 9, which is also in the Lesser Antilles.